go. Now we see them nice and big.
Okay, cool.
Ready whenever you're ready to start.
Okay. All right, so I'm Joey Pratt, and like many of you probably, I grew up getting into this kind of creative tech mentality where it's pulling things apart and sort of researching like the different parts of them. And so like going online and researching things through YouTube Academy or through different online resources. Well, that kind of started my passion for electronics. And then I'd go into my high school years kind of with that passion. So I was able to go into a national competition called Science Olympiad and do things like robot arm and circuit lab and have this knowledge of different components behind me. Well, that kind of further built up my knowledge, but also this passion for electronics. Now, coming into my college years, I had passion, but I also got involved with the youth center. And so the youth center had different people doing like music. And so I decided to do technology inside of the youth center. And I started a program teaching the types of things that we learn in creative technologies. Well, as a result, I ended up being honored by Barry and as a student leader and was able to get recognized for my work in the technology program. And that kind of opened a few doors. I remember being in a meeting with Zane, and then Zane talked about a open door home opportunity where I could go and teach creative technologies over at the open door home. And I was then able to teach high schoolers about the types of things that we learn in creative tech, like electronics and different creative avenues they could use in order to bring their ideas to life. And that eventually led to a study abroad with Zane over in Norway, where we were actually able to get past a language barrier and go.
Hey, Joey, I think we lost your sound. Nope, I don't think, Joey, we still can't hear you.
Oh, he may not can hear us.
All right, I'm going to send him something. Joey.
Wave your arms around.
You might need to hop out and rejoin, Joey.
Oops. I saw the blinking, but I didn't have the chat window blinking. Okay.
There we go. All right. So can you back up a couple slides? We lost you a little while ago. Other way.
Okay.
Going back. No, not that far.
Was I on the theme?
Yes, this is where you were.
Okay.
You want to start from here?
Okay. Yeah, so my theme is educational technology. And educational technology is all about helping others to understand the physical world by inventing technology and curriculum that assists them in the learning process. And so you'll get to see a couple different technologies I've designed, a couple different curriculum that I've designed in order to help people through the learning process. So my first example of this is educating others about electric flow that happens all around them. So you can see that I've got a circuit in the side, but it uses some unique components. So these students are building circuits using LEDs, resistors, and copper tape. Copper tape acting as our wire. And so the students can then get an idea, like a physical representation of electricity flowing through wires. But I also had this train analogy. And so you can imagine a train flowing from one part of the map to another. Well, we've got different parts of a circuit that I can then explain to them. One of those is a resistor. So a resistor, I would draw it out like this and then paint the picture of a train moving through mountains. So you can imagine the train moves through mountains and then has to slow down in order to go through the circuit. So you can then get a picture of what a resistor does, where it slows down that current running through the resistor. And so that train kind of just paints the picture for them. Do we need Chris, or should I keep going?
Go ahead and keep going. He'll
Okay.
rejoin.
Okay. So this all started in Norway, where I was trying to get over that language barrier. So I used things like trains as an analogy, but now I'm able to use it whenever I teach. So wherever I teach. So started in Norway, and then I'm taking it out into the community for other places. Okay. The next example that I have is rainbow arrays. So this one's all about educating others about the abstract concept of arrays. So arrays can be this abstract concept that high schoolers and even college students have difficulty learning. And so I wanted to create a technology that helped them through that. And so arrays are all around us. You've got seating charts and movie theaters and stadiums to shopping lists. So they basically have to be able to visualize these things pretty well. And so I made a UI that's in the bottom left corner, and it kind of helps them through that process. And so they get to pick a part of the array. So learning about indexes. And then you can see that I start at 0, and that's to help them through the idea of that things start at 0. But I also talk about like data types. And one of those data types, the one used in this example, is color. And so they're able to mix those colors around, and at the end, when they've got their data type and they've got their index picked out, they can send it off to the array. And that's the example that's seen above, where they can actually visually see their color on the physical array. But yeah, so it teaches them like the indexing, the array sizing, and the data types. And then they're able to very visually see an array. And I made this in my last hackathon, so you might see some spelling errors, but the physical prototype's here. Okay. The next example is the fresh meat notifier. So this is something that I made my freshman year, or not freshman year, but my 101 class, where I was educating frozen good owners, or so people who own freezers, about the status of their goods. And so this device works to keep their possessions safe. And so you can imagine being away from your meat for a period of time, that there's a certain level of danger of either the freezer failing or your power going out, something to where the fresh meat notifier can step in and help. And so we've got it measuring the temperature inside of the freezer to get that data in, and then helping us to visualize that data. And so anyone who's around that freezer, if like the freezer fails, can see the LED changing color. And so we've got two ways to visually see this. So it's got a threshold that's around like 30 degrees to where the to where meat starts going bad, and so we're wanting to give a visual of that threshold being crossed. And so red was used to say that things are getting too hot within that freezer, and it's kind of that real world making its way into this technology. And next we've got online visualizations. So you've got a freezer fits well. So it's the visual that you see in the top left corner. And so you can see you've got a history of where the freezer has been, and you can also see like the current temperature of that freezer. And so that helps you to go back and like backtrack on things. Really, what this service does well is text messages. And so I'm able to go in, and when a certain threshold has been crossed, send a text message to the owner of these frozen goods. And so when you're away, then this device can then communicate to you that, hey, your meat is in the danger zone. And this gives friends and family of mine the ability to kind of see what's going on with their meat. It gives them peace of mind. Dad was asking about it the other day too. So yeah. So it's still in use. Yeah. And then our next one. So this is the ultrasonic theremin. And so in case you haven't seen a theremin before, it's this instrument that's able to manipulate sound waves. And so we've got two components of this instrument. We've got the frequency, where you move one hand either up and down or side to side, and one hand that changes the amplitude or the volume to when you're turning or when you're doing the opposite motion. And so my instrument here uses a distance sensor on the side to change the frequency or the pitch of the notes, and then one on top that changes the amplitude or the volume of the instrument. And what this allows kids to do is have a fun way to experiment with sound waves, learn about sound waves, but also make their own music with electronics. And so they're not only learning about music and sound waves, but they're also learning about the science behind those sound waves. Okay. And then on to my my final project is the cart assistant. So you can imagine going into a store and having this hassle of having to find where new items are. And so this is working to get around that shopping hassle and also kind of make the shopping process more efficient. And so it's educating shoppers about the best path through the store, saving that shopper time. And so we've got two cameras on here. One's got an IR filter so that it can only see the infrared light that's inside of the room. And so the other camera is just a regular RGB camera giving a real world example to the shopper. And so we then take this infrared data, and we're able to analyze pulsing of infrared light. So this is done by some IR beacons. So the IR beacons are pulsing the user to go a certain way. And so you can see in the top left that we've got a turn back message. So that turn back message is actually coming from the analysis of these IR beacons. And what it can then do is guide a user through a store. So imagine that you're trying to find a bat in the store for your kids. And so you go and you add that to your shopping list. Well, that shopping list is automatically organized in the right manner so that you can go and go through your other items, but then select bat to be guided over to the bat. And so it'll ask you to turn around, it'll ask you to go forward and right and left. But once you've found that bat, you can then click found it, and then it'll remove it from the list and you can continue on with your shopping. And so organized shopping lists is a big deal about this because we're trying to find that most efficient path through the store. Okay. And finally, my future plans, what I plan on doing. So I want to continue to help others understand the physical world by inventing these technologies, this curriculum that assists them through this learning process. So I definitely want to volunteer in the area if I don't find jobs. I feel that volunteering has really helped me through my college years, and so I want to continue on with that. But right now, I'm researching jobs instead of education. And that's my presentation.
Nice. Thank you very much, Joey. So, all right, let's go ahead and open it up to questions and critique.
Can you give us an example of a place where you had to iterate or pivot or change what you were doing because your initial direction wasn't working quite right?
Okay. Yes. So